Hey guys, this is the screencast for question 3. I didn't break it apart into the different A, B, C because sort of they all work and flow off of each other, but you can follow along on your sheet. So we have a 100-kilogram man. He's being pulled in a bunch of different directions, but we're looking for, when you see these words, bird's eye view or from above, what that means is that automatically normal force and the force of gravity, exactly, or yeah, normal force and the force of gravity cancel each other. They have nothing to do with this problem whatsoever in terms of the motion. This guy's moving forward and back or left and right. We're looking from above, so that's how I'm going to draw the picture, but the up and down part of it is not involved in this problem. He's not getting pulled down, not getting pulled up, not getting pushed down, not getting pushed up. Those are totally balanced and thus have no effect on the actual motion. So what we're looking at is, I'm going to change this free body diagram from what's on the drawing just a little bit, because what we're looking at is the top of the guy's head. So this is the top of the guy's head, and his eyes would be there. So to him, he's getting pulled forward, so up is forward, and usually that's kind of how you want to relate it. Just pick a direction and stick with it. So I usually say that on these types of problems from a bird's eye view, up is forward because it just makes sense. So up is forward, and he's getting pulled forward with a force of tension of 40 newtons. All the forces are through force of tension, so force of tension that way is 40 newtons. If that was forward, then to the right would be to his right. Simple enough there. Force of tension to the right, according to the problem, is 20 newtons. To the left, 25 newtons. So basically he has ropes pulling him on all a bunch of different sides. And we got to figure out which way he would actually move as if there's no friction, so he's standing on just a bunch of ice. Sorry, that was my cat. Standing on a bunch of ice, so we've got to figure out what actually is happening. There's one other force. This is the tricky force, the thing that makes it two-dimensional, of 18 newtons, where this angle is 30 degrees. And I'm going to apologize because in class I gave you something which in this problem doesn't work. In class I said that Fy is hypotenuse, FHYP, you'd probably seen this equation, times sine of the angle, and Fx is FHYP times the cosine of the angle. What I didn't tell you was that is only true if the angle is with respect to WRT with respect to the horizontal. This case we actually, and I won't do this on a quiz or test, so these are still very valid. Sorry for crossing that out. It's only true if it's with respect to the horizontal. This angle is with respect to the vertical. It's touching the backwards direction, if you will. So actually, when that's the case, these switch. And I should have mentioned that. I truly apologize that I didn't. So that's probably, and could be a very easy source of confusion. So when it's with respect to the vertical, this switches. This is the only problem in which I will tell you that. So really, what we care about is an angle. It's true now if we use this angle of 60 degrees. So our new angle is not going to be 30. We're not going to work with 30. We're going to work with 60 degrees. So if we use 60 degrees, then we are measuring with respect to the horizontal, and we can use these actual equations. So anytime you see an arrow that is or an arrow that is not at the right angle, then, sorry, my cat keeps walking by. When we see an arrow that is at an angle with respect to something else other than the coordinate axis, that's the thing we have to break apart. So we only have one arrow to break apart, and that is this one, the 18 newtons, where with our new angle, 60 degrees. So it's going over and down. So this is going to be our F. In this case, it's an FTX, tension, horizontal tension force. And this one is an FTY, vertical tension force. So we just use our equation, FTX equals 18 times sine. Again, we switch that angle, so now it's 60 degrees because it has to be with respect to the horizontal. And FTY, 18 cosine 60. You could have easily just kept it if you looked at just the triangle itself. The opposite side is the horizontal piece. That's what causes it to flip. But working it this way keeps things a little bit more continuous. So 18 sine 60 is 15.59. And 18 cosine 60 equals 9. So we're good there. I messed those up. Fy deals with sine. Apologize. Flip that around. And that's okay. What I'm doing is I look back and something caught my eye. You might have seen that in my face when I was looking at it. It's okay. I realized that something wasn't right. I went back and I said, all right, well, looking at these equations, fx deals with cosine. I had written it, ftx is sine. I go backwards. So I look at this angle. I'm trying to find sine. Sine is the opposite side. That's my fty. So it's backwards. fty, this one's ftx. Again, by doing that, you get rid of your angled arrow, and we replace it with two different arrows. We replace it with a down arrow and a secondary over arrow. Put those together on our free body diagram, and we get a down arrow, which would be our FTY of 15.59. I'm going to drop all of these tensions. They're all there. Yeah, I'll write them. FTY. And then our up force, FT, just a separate FT, 40 newtons. Our right force, another FT of 20 newtons. We have two leftward forces. One is 25 newtons. And the other is what we just found, of 9 newtons. So, in this case, that's our free body diagram. Really, parts A and B are the same thing. You have to do part B in order to find part A by breaking apart this angle. So finding these two is really solving for part B. Putting everything together is solving for part A. Determine the net vertical force, part C. Well, the net vertical force, we only have two forces vertically. F net y is our vertical force. You do total up minus total down. So really, in this case, it's total forward minus total backwards, which gives us 24.41 newtons. Hold on to that for a second. We've got to find part D is our total horizontal force. That's total right minus total left. Our total left is 25 plus 9. 25 plus 9 is 34. 20 minus 34 gives us negative 14. Negative just means to the left. So negative 14 newtons or 14 newtons left. Part E says recombine these forces. So we have a net vertical force going 24.41 newtons up. We have a net horizontal force going 14 newtons left. So we got to recombine these. Doesn't matter which way you do it. I'm going to do the F net x first. So our angles with respect to the horizontal. And then tip to tail. Tip to tail, 24.41 0.41. So my hypotenuse is my overall net force. You have the components, the overall net force is your full true thing that you're looking for. So our overall net force, Pythagorean theorem, plus 14 squared, square root, 28.14, just Pythagorean theorem, 28.14 newtons. But we also have to find the angle. Net force is a vector, so we've got to find this angle. So to find the angle, use inverse tangent. Inverse tan, in this case, 24.41 over 14. We're going to get an angle, inverse tangent, 24.41 over 14 of 60.16 degrees. In this case, it's a little hard to identify the angle. I'd be very lenient. You could really just say AH. But as I was talking about it, where up is forward, it would be forward, even I'm having trouble with this one, of left. Very weird way to word the angle. Just keep it as AH. It's simple. The last thing I have to do, so this right here combined, put it all together, my net force is 28.14 newtons at, put it all together, 60.16 degrees AH. On the next slide, I've just got to show what the acceleration is. So, acceleration, our net force, oops, hold on. Our net force was 28.14. 28.14 newtons at 60.16 degrees above horizontal. Our net force divided by our mass is our acceleration. So we have to divide the mass. Mass is 100 kilograms. So I can do that in my head. 28.14 over 100 is 0.281. We'll go to 3 decimals. Meters per second squared. Whatever the direction of the net force is the same direction as the acceleration. 0.16 degrees above horizontal. There you go. Our mass was 100, so 28.14 over 100 gives you the 0.2814 if you want to keep an extra decimal. Acceleration as units meters per second squared, and we're good to go. So this one was a little different in the fact that we had to break it apart, and then because he was moving forward and to the left, we had to recombine it all together. So it was sort of an extra step, but hopefully you were able to follow along, and good job.